2, 1. All right. Hello, everybody.
Hello.
All right, we're going to jump straight in. So today we were working from the Primary Connections book, Essential Energy, which links straight to our physical sciences stream for our Year 6 students. So before we get started, it is important to take a step back and explore the term energy. So when we hear the word energy, we may associate it with everyday terms such as the way we are feeling or how active we are, or the energy that's on the back of food labels. It could be the energy that we use to drive our cars or pedal a bike, or even batteries. But it has a different meaning when it comes to science. So energy is defined as the capacity to do work. So there are many different types of energy, such as movement, electrical, heat, chemical, nuclear, light, elastic, sound, and gravitational energy. As we have come to learn over the duration of this unit, energy can be transferred or transformed, but it cannot be created or destroyed. So our lesson, Here Comes the Sun, on page 30, is the third lesson of the sequence. So it provides hands-on shared experiences of a simple energy transfer. So an energy transfer takes place when energy moves from one place to another, or between objects. An example of an energy transfer can be as simple as kicking a ball with your foot, as the energy is staying the same and it is only being transferred between two different objects. So energy can be transferred through light, sound, and heat also. It is more useful to explore its characteristics and describe what it does. For this reason, we will investigate how different materials change the way that an energy can be transferred and the effectiveness of it. So the ultimate goal for our students is the willingness for them to engage in science-related issues. It is by relating these scientific concepts back to students in a real-world context that they can fully engage with the learning. In addition, our emphasis is placed on critical and creative thinking to think outside the box and create abstract solutions to real-world problems regarding sustainability. So having this knowledge and skills helps to develop responsible citizens who are conscious of the surrounding world. So in session 1, we explored the different types of energy, whereas session 2, we looked at how certain appliances in the home environment use energy. For the case of today, we are going to look at how changing certain properties affect the energy transfer. So in particular, we will be modifying a soft drink can to investigate how to heat the water faster. We will be recording how quickly the temperature of the water increases and how long it takes for the maximum temperature to be reached. So for the sake of today, we have already set this up as this is an hour-long experiment, but we're going to be checking on it as we go through the Zoom and recording those that information as we go. So what you're going to need for the experiment is 4 empty soft drink cans, a measuring cup, a bucket of water to fill the cans with, 1 thermometer, our science journals with a printout of the resource sheet that I have here, a stopwatch, and some equipment for modifying cans. In this instance, I'll show you with what we've got set up. So if you have a little look here, we've got our alfoil tray, we've got our cling wrap, we've got our can that has been painted black, and we have our plain can. Alrighty, so let's get into it. So Darcy, do you have anything to say on what we're investigating today?
Yes, so this week we are going to be investigating how energy from the sun or solar energy can be used to heat water. And the question we are asking is, how can we heat the water in the can faster?
Awesome. All right, so what did we predict as our initial hypothesis?
So we could predict, and students will probably predict, that the can painted black will heat up the fastest because black absorbs heat.
All right, so that's what we've been learning so far. And our students will be recording their findings using this resource sheet. So it's located in their science journals for them to refer back to any content that we've explored in the unit to consolidate their findings, or if they have any questions. So as you can see here, we have filled out the prediction section of the table already, which we thought the black can was going to heat up the water the fastest. So now we're going to move on to the reasoning section, asking why do we think that particular modification will cause the water to heat up the fastest. Next is the observations, which we will record the time, the temperature of the water in the plain can, and the temperature in the modified cans. So we've got a bit of comparison going on there. And finally, once the experiment has been completed, we will have time to discuss our observations and the science behind why it happened and be able to fill out the explanation part of our table. So what we're going to do, we're just going to quickly take, I've already taken the first two. So our initial one here, so it was room temperature water, which was 22 degrees in all of the cans because we all had the same water to keep it a fair test. And then at the 15-minute mark, the temperature in the plain can was 23 degrees Celsius. The temperature in the black can was 25. In the alfoil tray, it was 23, so a little bit lower, and it was also 23 in the cling wrap. So it didn't really go up very much for those two. We're just going to quickly take this one here. All right, so I'm going to grab my thermometer. All right, so the alfoil one. And a nice accurate reading. Let it sit there for a little second. So it's slowly going up. All right, we've just hit the 25 mark for the alfoil. So that one has gone up slightly. 25. All right, the cling wrap. Let's have a little look at this one. Wait a little second. The cling wrap has gone up to 24. So it's gone up by 1. 24. Not much change there. In the black can, let's have a little look at this one. All right, it's rising. Okay, so this is our 30-minute mark. Oh, I can see here. Have a little bit of a look. Wow, so that one's gone up quite a lot. We've gone up to 30 degrees.
Huge news.
30 degrees. And last but not least, our plain can. So this was our initial one. And that one's a little bit lower. It's gone to 26. All right. Beautiful. Let's keep going. Okay. We've got all of our measurements. So it is important when carrying out the activity to keep in mind having a fair test. So we need to have the same quantity of water, which was the 300 mils, put into the cans in the same spot, and they haven't been moved for the same amount of time. In this case, the variable or thing that is changing is the way that we modified the can. So to help us out here, I've already prepared it. We've started off with our measurements and we're at the 30-minute mark. So we've got one more to take and then we will be ready to go. So we're going to do this 4 times to make it 1 hour. Now we're going to have a little bit of a look at our observations. So what did we see here? We saw that the plain can changed a little bit, not much in temperature, as it sort of stayed about that room temp. Did anyone else sort of have anything they wanted to say?
The
painted can, it did heat faster, but when measuring the temperature, it was hot to touch, like on the outside.
Yeah, so we can imagine that, you know, when we're doing that, because it is painted on the outside, that it is going to be a little bit hotter when we touch it.
Especially after an hour, when the students are doing it for an hour.
Yeah, absolutely.
Yeah,
and taking into mind, the time of day that we're doing it. So the sun is out, it's very bright and shining today.
Yeah.
Great. I think it's also obvious from what you showed us just then with the cans that the Glad wrap, you said it was slightly cooler than the others. So look, it's probably insulating it, you know, not letting the heat out and things like that.
Yeah,
So
keeping it all on the inside.
Yeah.
Yep, good observation. And we can also see that the the alfoil, it has that really bright reflection off it. Obviously, those sun is coming down, hitting that alfoil, and the light is reflecting back. So that's obviously going to have a little bit of an effect on the on that can there as well. So
Is that one a little bit cooler though?
the outside of the can was cooler, but on the inside, the alfoil, so it went up by 2 degrees. So it's still
Okay.
it's slowly heating itself.
Right.
Yeah.
So now we're going to move on to our inferences. So using science to prompt our answers to our questions that we had at the start of the lesson, why do we think that the water in the cans are heating up quicker than the other modified cans? Also, what sort of patterns can we see that are coming up here? So we had a little bit of a discussion about how the black can is heating up the water the fastest than over the other cans. However, the water didn't get as hot as we have expected. I did expect it to be a little bit higher. So maybe we can, this modification can be used in combination with other modifications to get an even better result for heating up our water. So the black can did heat up the fastest as it absorbed the radiation from the sun. It was able to hold onto the energy and not release it through conduction into and around it. The color black reflects less light, therefore it will be absorbing more energy than in the heat, like to heat up the water in the can. And the plain can did not heat up as quickly because the silver color reflects more light, meaning less heat is trapped and therefore there's less energy in it. So moving over to our final hypothesis, what did we think, what did we come up with there?
So I think for a final hypothesis, the black can is the best at absorbing heat radiation from the sun, as it does not reflect the radiation back and traps it inside.
Yeah, absolutely. So when we're looking at our final and our initial hypothesis, what comparisons can you see there?
Yeah, so comparing our initial hypothesis and final hypothesis, we can see that we predicted what would happen was correct. So we were correct in our initial hypothesis. This is due to us bringing our prior knowledge and past experiences to this experiment to initially hypothesize. However, we did learn that although the black can heated the quickest, it was slower than expected. So we did think it would heat up a lot quicker than that. Other materials to help the energy from the sun transfer into heat at a better rate though.
Yeah, absolutely. All right, so that takes us over to our CDSU. So what have we got to say in terms of that?
I think so. Basically, we'd start with, look, heat travels from the sun in the form of infrared or heat radiation. We'd also look at the science behind the certain colours and materials that are best at absorbing heat. So matte black is the most efficient at absorbing heat as it traps in the radiation. Silver is the worst as it reflects the heat energy away and does not retain that energy, therefore not heating up the inside. The radiation from the sun heats the earth and is transferred to objects. Some objects are better at retaining the heat and absorbing it, as we discussed. Infrared radiation or light is part of the electromagnetic spectrum. So this travels to earth in waves. When it hits something that is a dark color, light's absorbed and converted into heat energy. If a light wave of a given frequency strikes a material with electrons having the same vibrational frequency, then those electrons will absorb the energy of the light wave and transform it into vibrational motion and thermal energy. So that'll heat it up. The light wave with the same frequency as the electron is absorbed by the object, never again to be released. So it traps it, heats it up.
Yeah, so basically just what Beth just said, the black material allows the light to absorb the heat as they have the same vibrational frequencies. And so yeah, when the light wave strikes an object that does not have the same vibrational frequency, the energy is re-emitted back out as a light wave. And if the object is rough or uneven, the light will be re-emitted out into all different directions. And we can also go back to the Glad wrap can there. It's been insulated, so it's retaining either the warmth or the cool temperature. So that's why that one's a little bit more colder than the rest, because it's been insulated by that Glad wrap, such as materials like plastics and whatnot.
And we also know that when light hits an object, that light, known as white light, contains all visible wavelengths of light. So like with colours, a red shirt will thus appear red because it absorbs all the wavelengths of light except for red, which reflects back to our eyes. A white shirt reflects all the wavelengths of light back to our eyes, absorbing none of them. A black shirt, on the other hand, absorbs all the wavelengths of light, reflecting none of them back to our eyes. As a black shirt absorbs all the light that it hits, it converts that light into other forms of energy, usually heat. It then emits that heat, some into the environment and some directly into your skin. This is why people advise against wearing black or dark clothes on hot days, because it makes you so much hotter. And so that's why, lighter clothes are better, because you won't get as hot on those hot days.
Very true.
All right, so that takes us over to our relation to our science content knowledge and our curriculum links.
Yes, so this experiment directly relates to the Year 6 content descriptor. Electrical energy can be transferred and transformed in electrical circuits and can be generated from a range of sources. Students in the explore phase are building their scientific literacy, adding vocabulary terms such as transfer, transform, in relation to energy, conduction, convection, in relation to heating, and transparent with the materials used. So as also investigating the use of solar panels is an elaboration of this content descriptor, which can be used as an extension activity for students where they design their own solar panels now that they have an understanding of the sorts of materials that can be used to help heat water faster.
Yeah, so we also have considering whether an energy source is sustainable. So that's another elaboration that we can work with here. It really correlates with the science as a human endeavour strand, getting students to consider the effects of their actions in everyday life. So being aware of the environmental footprint they leave in terms of the energy they use. So very on topic at the moment in the world. And then obviously from the science inquiry skills strand, we focus on the content descriptor. Decide variables to be changed and measured in fair tests, and observe, measure and record data with accuracy using digital technologies as appropriate.
Yeah, so that then brings us over to our alternative concepts. So students may have misconceptions of the use of the word energy, as it is such a commonly used word in our everyday lives. But obviously, as we talked about, when it is used in a scientific setting, it has a different meaning. So we really need to give lots of examples as to how we can use it in our science classrooms.
It would also be important to point out that there needs to be clear explanations and a wide range of examples provided for terms such as transfer and transform, as students may use them interchangeably. Yeah.
And also another conception is that energy is only found in living things. And we know that this is incorrect, as everything has energy in some kind of form.
An object can only, another misconception is that an object can only be heated through solar power if the sun is like directly shining on it. This is not true, as the rays can be refracted and bounced off of a surface onto the object. So it doesn't necessarily need to be shining straight on it for you to get that solar power in your house, etc.
Yeah, as well as that light can only be reflected from shiny surfaces such as a mirror. So that's a misconception students might have as well. Yeah.
And lastly, another misconception is that the Earth gets its heat from the sun. So this is actually, the sun is actually too far away from the Earth to heat it directly. Instead, the light from the sun is reflected and absorbed by objects on the Earth. So absorbed light usually increases the energy of an object, causing the object to heat up. So that's another misconception we need to be mindful of. And moving on to our pedagogical content knowledge.
Yeah, so for this experiment, an inquiry-based approach was used, aiming to create hands-on experiences for everyone. For this reason, mimicking real-life contexts and experiences. We also used household items so that it was relatable for students rather than abstract materials that may confuse them in the explore phase. And this in turn aids students' understanding and interpretation of the new concepts and the concepts involved.
Yeah. So this then links us to our understanding of science as a human endeavour and how we can include that in our learning.
Yeah, so Obviously, we use energy to make changes in our surroundings, such as we heat rooms, freeze food, and communicate using light, sound, and electricity. Power stations and local solutions, such as batteries, provide us with electrical energy that machines transform into the useful energies that we require. There are many different ways that we can use the Earth's resources to generate energies we desire. And the Essential Energy Unit provides opportunities for students to explore how energy is used to make changes in the world, including energy from the sun, water, and wind. It also allows us to discuss the advantages and disadvantages of using the sun to heat water for a shower using this method compared to other forms of heating.
Yeah, so I guess that sort of brings us over to some questions that we could be throwing out at the students, like how many cans of water would you need to heat in your everyday lives or when you have a shower? What would you do on cloudy days? Like how could we factor that into our learning? Could you store heat energy from the sun? What are the advantages of heating up water in this way compared to others? So they're just a couple of questions about how we can explain how this relates to us in our everyday lives. And just to kick us off, we have one final measurement to take just to consolidate all of our learning. And then we are done for the day. So starting with this one, we have moving up. We can see that the alfoil tray has 26, so it's gone up by 1.
Mm.
We see that the next one, our cling wrap, so it was on 24, and we can see that it's staying the same, so it's keeping that energy in.
Insulating.
Okay.
Nice.
24 is the same. Now this one,
This will be interesting.
Yeah.
so it's quite hot to touch, we can see. Oops, it's heating up very fast. So it was on 30, and we can see it's still slowly rising at 30. So it's now at 41. So that's gone up quite a bit.
Oh, wow.
41.
Gone up a lot.
I actually didn't expect it to go up that much. That's that's lit.
And the last one,
Wild.
our plain can. You can see it's slowly going up there. This one has going up to 30. So it's gone up by 4. So
Oh, okay.
It's lower, but still getting there. How good.
all right, so that kicks us off for today. We are all done with our Essential Energy Unit. Thanks, guys.
Perfect.
Thanks. Bye.
Thank you. Bye.
Did I just end it?